Okay, so the other day we factored these that have a coefficient in front of the x squared only by guess and check, right? So it took a lot of like factoring, like finding factors and figuring out which ones multiplied and added and all the fun things, right? So today I'm going to show you another way to do that. I still stand by my guess and check is the best way for this. I still firmly believe that, but I'm going to show you another way in case you don't love guess and check like me, okay? So AC method comes from this expression, ax squared plus bx plus c, which they use to call these whenever your coefficient in front of the x squared or your a is more than 1. That's why that looks like that, okay? What does it normally mean when you have or two things right next to each other in math, like a letter and a number or two letters? What? Multiplication, right? So that's exactly what we're going to do, is we're going to multiply this a times this c. So on our first example, I'm going to multiply 8 times negative 3. What is that? Negative 24. Now I'm going to use that negative 24, and I'm going to find factors of negative 24 that add to give me negative 10, which I pulled from the middle term. Similar to what we did when there wasn't a number in front of the x squared. So what are factors of negative 24 that add to give you negative 10? I'm going to go with 2 and 12. 6 and 4 would add to give you 2, because one of them has to be negative. Okay, but if you do negative 12 and positive 2, that's going to multiply to give you negative 24, add to give you negative 10. 6 and 4 is my favorite wrong answer there, because that's the one everyone picks, just so you know. Okay, so now I have these factors, but I can't just put it straight into parentheses like I did last time, because I have this 8 in front. So what I'm going to do is I'm going to take my first term that includes a, my last term that includes c, and I'm going to leave them alone. I'm going to leave them exactly as they are. So I'm still going to have 8x squared, and I'm still going to have a minus 3. But I'm going to take that middle term and split it up into two middle terms using these two factors that I just found. So I'm going to split negative 10x up into negative 12x plus 2x. So now how many terms do I have? 4 terms. What did we do when there were 4 terms the other day? We did grouping, right? Grouping 2 and 2. And then from here on out, it's exactly like factoring by grouping. So your GCF from the first 2 terms is going to be 4x. When you take that out, you get 4x times 2x minus 3. What's my GCF from the second set of 2 terms? Just 1. So a plus 1. I'm left with 2x minus 3. The stuff inside the parentheses are the same. So that's going to be my first factor, 2x minus 3. My second factor is going to be those GCFs, so 4x plus 1. So if you hated guess and check, here's an alternate method. Okay, we're probably going to do these 2 at the top and then move to the next page. So part B, what's the first thing you always look for when you factor? A greatest common factor. What is my GCF? 2. So I have a GCF of 2. So I have 2 times 10x squared plus 11x minus 6. Okay, if an expression has a GCF, it may continue to factor after you take that GCF out. A lot of you forgot that that could happen on your quiz. Okay, so after you take out the GCF, you still have to go back and check to see if what's left on the inside will factor. Okay, so we're going to do AC method again. You could do guess and check because there's 3 terms. There's a number in front of the x squared. You could do guess and check if you really like that. If you hate guess and check, then we're going to do AC method. And I'm going to pretend like this 2 isn't here. So I'm just going to cover it up and kind of ignore it for a minute. And I'm going to do exactly what I did on part A. So I'm going to multiply A and C 10 times negative 6, which is negative 60. I need factors of negative 60 that add to give me 11. Anybody know that one off the top of your head? No, it's really early for math today. I'm going to go with 15 and negative 4. So just like last time, the term with A and the term with C stay the same. So 10x squared does not change. This minus 6 at the end does not change. And then I'm going to split this 11x in the middle into plus 15x minus 4x from these 2 terms that I just found. Now it's your regular factor by grouping. When you do that, you get 2x plus 3 times 5x minus 2. You guys did really well on factoring by grouping on your quizzes, so I didn't feel like I had to talk you through that. But I still have this 2 up here that I'm covering up, right? It didn't just go away and disappear from the problem. It's still there, and you still have to put it out in front. So even though I've ignored it this whole time, I'm going to bring it down, put it in the very front, and then I will circle my answer. Okay, I'm going to let you start this next one without me. 4x squared minus 19x minus 30. Have you found the drawback of the AC method? Okay. Sometimes when you multiply A and C, you get giant numbers like negative 120, right? Which is not on your multiplication table, which makes it kind of hard to figure out your factors, right? So if you have a calculator, it's fine, because then eventually you can find those things. But if this is the test and you multiply and you get a number that's not on your multiplication table, then it requires a little bit more work. This is why I like guess and check best. But this will still work. Did anybody find it? You found it?
Oh, no.
Oh. Oh. That's a negative 19x. Sorry. Okay. So nobody found them? It's negative 24, positive 5. Okay. Now go ahead and factor it from there. Okay, so hopefully you got x minus 6 times 4x plus 5. Okay, so do you like AC method? Yeah. What?
It depends.
It depends. Exactly.
I like it the first few times.
Agreed. Okay, so I'm going to skip these next two examples I have on this page, and we're also going to leave page 17 blank for right now. So I'm going to reserve page 17 for our review day that we have next week before your test. Okay, so we're going to go to page 18. We're going to glue in that factoring difference of squares from your sleeve. Again, this is page 18, not 17. Okay, so factoring difference of squares. For this to be the kind of factoring that you can do, the degree must be even. So it has to be like an x squared, x to the 4, x to the 6, etc., etc. An even number as your biggest exponent. Okay, on all of those examples down there, how many terms are there? On all of these examples, how many terms are there? 2. So there has to be 2 terms, meaning it is a binomial. And your A and C must be perfect squares. Where are the perfect squares on that multiplication chart? The diagonal, that highlighted diagonal I told you you needed to memorize, or you needed to know well. Okay, and then there's one more thing that some people feel like is obvious, but some people feel like it's not. What does this word right here mean in math? Subtraction. This symbol right here has to be a minus sign. If it is not a minus sign, then it's not the difference of 2 squares. It's the sum of 2 squares. And then you cannot use this method. So our steps for factoring, you're going to take the square root of A. Actually, I'm going to say ax squared. That's going to go in the first set of parentheses. And then you're going to take the square root of C, ignoring the minus. So if you try to type in the square root of a negative number in your calculator, it's going to tell you an error. So you can't take the square root of a negative number and get a real number answer. We're not there yet. Okay, so you're going to ignore the minus and you're just going to take the square root of C, no matter what it is. That's going to go second in each set of parentheses. And then you're going to make 1 factor plus and 1 factor minus. Okay, I'm actually going to skip this first example for a second. We're going to go down here and do A and B first. I'll give you a second to write those down. Yeah, it's on the bottom of page 18. Yes. Bless you. Was this the class we had the discussion about whether you sneeze or cough in the mask? See? I don't know what to do. Still haven't gotten a good answer on that. I do too. But then I feel like that's the whole point of a mask. I don't know. Anyway, off topic. Okay, so what's the first thing you always look for when you factor any expression ever? Greatest common factor. Do I have a GCF between these two terms? Nope. So I have no GCF. So I'm going to take the square root of each one of my terms. So I'm going to take the square root of 100x squared. What's the square root of 100? 10. What's the square root of x squared? X. Then I'm going to take the square root of 49. What is that? 7. Okay, when I factor these, I'm still going to have two sets of parentheses, like I've had every time so far, right? I'm going to put a 10x in front of both of them. I'm going to put a 7 in the back of both sets of parentheses. And I'm going to make one positive and one negative. And I recommend always putting the negative on the second one. I'll explain why, but that's just my recommendation. Okay, that's my factored answer. That's all there is to it. And I'll show you why it works. So when I multiply, you remember this from guess and check, 10x times 10x is going to give me that 100x squared. 7 times negative 7 gives you that negative 49. Your middle term comes from the outside plus the inside, right? 10 times negative 7 is negative 70x. 7 times 10x is positive 70x. What happens when you add those together? They cancel. So that's why this formula works, is because every time those middle terms are going to cancel out, because your first terms and your last terms are the same. The only difference is that sign in the middle. Okay, so let's do part B. Same way. Do I have a GCF? No. I'm going to take the square root of each term. So the square root 16x squared is what? 4x. I'm going to ignore that negative. What's the square root of 81? 9. Two sets of parentheses. 4x in front of both. 9 in back of both. 1 plus, 1 minus. And there's your answer. And you go to check it. 4x times 4x is 16x squared. Positive 9 times negative 9 is negative 81. In your outside terms, 4 times negative 9 is negative 36. Positive 9 times positive 4 is positive 36x, which do cancel. So we did it right. There's my check. Okay, now let's go back up to this one, the one we skipped. Do I have a GCF between 81x squared and 36? I do. What is it? Yep. I have a GCF of 9. So you have to take that out first to get 9 times 81 divided by 9 is 9x squared. 36 divided by 9 is 4. So 9x squared minus 4. Okay, up until today, if there were two terms that you had to stop, all you knew what to do was to take out a GCF, right? Now, when there's two terms, you have to look and see if it's the difference of two squares. Is 9x squared a perfect square? Is 4 a perfect square? Are they being subtracted? Yep. So now we can factor it even further, just like we did down here. So the square root of 9x squared is 3x. Square root of 4 is 2. 2 sets of parentheses. 3x in front of both. 2 in the back of both. 1 plus, 1 minus. What else do I need in my answer?
9.
That 9, that GCF. Don't forget about it. And then to check, 3x times 3x is 9x squared, 2 times negative 2 is negative 4, minus 6x plus 6x cancels, so that will give us this. You multiply that 9 back in, you do end up with where you started. Okay? All right, so down here I'm going to let you do part C, and I'm going to change this one, so if you wrote it down, I'm sorry. Instead of that one, we're going to do x to the fourth minus y to the fourth there. I'll give you a couple minutes to work those two. Okay, on that one, your GCF was 16. A lot of people think that the GCF there is 4. Sadly, it's not. Okay, if you thought the GCF was 4, then when you take that 4 out, you would have had 4 times 16y squared minus 4, right? Even though those are still both perfect squares, you can look on the inside here and realize that you have another GCF still on the inside. So if if all of your terms on the inside of the parentheses have another GCF, all you took out was a factor, not the greatest common factor. So from here, you could have seen, oh, those are both divisible by 4. And you could take out another 4 and end up right here. This would have been an extra step, and that's okay. Did I have a GCF on part D? No GCF. Okay, when I took my square roots, what's the square root of x to the 4th? X squared. What's the square root of y to the 4th? Y squared. So you have an x squared, y squared, 1 plus and 1 minus. What do you notice about this, though? Aren't those both perfect squares? They are, which means that this is another difference of 2 squares. Mr. Stanbaugh calls these double dots. Difference of 2 squares, DOTS, dots. Okay, because there's a difference of 2 squares here. You factor it, you get another difference of 2 squares. Square root of x squared is x. Square root of y squared is y. Will this one factor any further? Why not? It's a plus, right? So that x squared plus y squared has to stay. But this x squared minus y squared will factor one step further to x plus y, x minus y. That might be a really good problem to know how to do at some point in the future. Just throwing that one out there. There's a non-hint hint. All right, page 19. That next paper from your sleeve. Perfect square trinomials. Okay, this is another one where we have some examples at the bottom, so you might want to glue this towards the top if you haven't, or if you put it at the bottom, you might want to move it up. Okay, so perfect square trinomials must be an even degree. So just like our difference of two squares, it's going to be an x squared, x to the fourth, x to the sixth, etc. An even degree. What does this word mean? 3 terms. So it's a trinomial because it has 3 terms. Okay, and then your first and last terms are perfect squares. So this is what they look like. Okay, I'm going to fill in my steps, and as I do that, I'm going to fill in these formulas up here, okay? So my first step, always for any factoring problem ever, is to look for a GCF. Once you've looked for a GCF, and you have one that fits this description, then we're going to take the square root of the first term. So for both of these, what's the square root of a squared? A. That's going to go first in your parentheses. And you're going to take the square root of the last term. Does that sound familiar? Does that sound like what we just did for difference of two squares? What's the square root of b squared? B. Just like last time, it's going to go last in your sets of parentheses. And you're going to decide on your signs. Okay, so on the last ones, if I made one positive and one negative, what happened to my middle term? it canceled out, and then I was only left with 2 terms, right? Do I want them to cancel out this time? No. So if it's a perfect square trinomial, if that middle term does not cancel out, then they're going to have the same sign. And it's going to be whatever sign is right there. So since this was a squared plus 2ab, this became a plus b times a plus b. Since this one is a squared minus 2ab, it's going to be a minus b times a minus b. Is there another way I can write this?
A minus B squared.
Yep. A minus b squared, or a plus b squared. So for these perfect square trinomials, you may not recognize right off the bat that it fits this description, because this one you kind of have to know and look for. If you don't recognize it right off the bat, that's fine. You can factor it like you would your other trinomials using the X method or guess and check or the AC method. But whenever you get to your answer, it'll look like this. And that's fine. You can do it that way. This is just a, hey, if you don't, or if you can, if you recognize it, it's kind of a shortcut. It's like a, hey, there's a pattern. I have a formula for that, so I can use it. All right. So if you are like, what in the world is she talking about? I don't really understand. Then factor it like you normally would factor one or a trinomial. But it may take you a little bit longer, and that's okay. You'll have plenty of time. So this example 1, what's the first thing I always look for? Greatest common factor. Do I have one? What is it? 25. So I'm going to take that 25 out. And that's going to leave me with x squared plus 4x plus 4. Just like every time I have a GCF, I'm going to cover it up and pretend it's not there. Now looking at this, x squared is a perfect square, 4 is a perfect square. So that tells me, hey, it could be one of those perfect square trinomials. So now I'm going to check to see if it fits this description up here at the top. Okay, so what's my square root of x squared? X. What's the square root of 4? 2. So my middle term, for it to be a perfect square trinomial, needs to be 2 times x times 2. Is 2 times x times 2 4x? 2 times 2 is 4, times x is 4x, right? So it does fit that description up there, so I can use this formula. Okay, so I'm going to go straight from 25 times x squared plus 4x plus 4 to 25 times x plus 2 squared. That's a plus b squared. Okay, so let's look at example 2. Do I have a GCF between all 3 terms? Nope, no GCF this time. Okay, if I was one of those fans of AC method and I had to multiply 16 times 81 to try to find factors, I think that would be very fun. No. So knowing my perfect squares comes in handy here because I know that 16 and 81 are both perfect squares, right? So I'm going to find my square roots and see if it fits my pattern from up there. So what is the square root of 16x squared? 4x. The square root of 81 is 9. And then I'm trying to get a negative 72 in the middle, right? So that's going to be my second formula because there was a minus. So I need 2 times 4x times 9. Well, what is 2 times 4? 8. What is 8 times 9? 72. So this does fit my pattern. It's going to fit this one. So I can automatically go straight from here to here. So this is going to factor 4x minus 9 squared. Okay. All right, go ahead and try A and B. Okay, so there are my worked out answers, and then there's one more for you to try. To look for that first every time. Okay, so we're going to take a break for a second. We're going to go on to page 8 in your notebook, because I want you to just be proud of yourself for how far you've come. Okay, so far in the past 2 weeks of school, you've learned how to factor by GCF. You learned how to factor by grouping 2 and 2. You've learned how to factor with the X method, guess and check, AC method. I didn't show you the box method because I don't like the box method, but if you still struggle with these that you could normally use guess and check or AC, come see me later and I'll show you the box method. I really am not a fan, but whatever. Okay, so you've learned all of these green ones, right? And you've learned the difference of 2 squares for 2 terms. So all you have left are cubes and factoring 3 by 1s, right? You should be pretty proud of yourself. That's a whole lot to do in 2 weeks, especially these 2 weeks, right? Of all the 2 weeks we've ever had in school, these have been pretty intense. which also means that we're nearing the end, right? Because my goal for today, in our remaining 35 minutes, I can count, is to get through these and this one. Okay? We're going to make it. I promise. All right. So we're going to go back to the notebook. And on page 20, okay, mine is going to look backwards. Because originally I was going to put this on 21, but I want to put it page 20 this time. It's going to be the sum and difference of cubes. So we're going to put this on page 20, not page 21. Okay, so on page 5, you have that multiplication chart, and over to the side, it has your perfect cubes. But since I don't want to have to flip back and forth to page 5 the whole time we work this page of notes, I'm going to go ahead and put them here again for you. So earlier we did the difference of two squares, right? So those were the perfect squares. They come from the diagonal on your multiplication chart. Now we're talking about perfect cubes, so numbers that have cubed roots. If I remember correctly, you didn't do a lot of this in Algebra 1 or geometry. So these probably don't come to mind as quickly as the perfect squares, which is fine, which is why I'm giving you the list, both right now and on the test. Okay, so this is for when you have perfect cubes, and it's the sum or the difference of perfect cubes, right? So again, these two formulas are used when you have two terms. Two terms. And what's really nice about these is if you can memorize the formula, you'll get them right every time. You can memorize the formula. So this is a formula you got to memorize. Kind of like difference of two squares. But once you know the formula, you'll be good. Okay? So a cubed and b cubed are both perfect cubes. So they come from this list that we just wrote down over here. And if it's two terms, it's called a binomial. So you may be wondering why the random word soap is right there. And the reason is soap is a way to help you remember this formula, right? So this tells you how to do the signs in your formula. So the signs in your formula, the first sign is always going to be the same as the sign in your expression. So this expression has a plus, so my first sign in my formula is going to be a plus. The second sign in your formula is the opposite. As the sign in the expression. So if this sign is positive, the opposite of that is negative. And then your last sign is always positive. So that b squared right there is always going to be positive. So the same, opposite, always positive. That's why you have soap on your paper. So when you have the sum of two cubes, this is your formula. If it's the difference of two cubes, notice your a's and b's and a squareds, all these things are the same, but the signs are going to be different. So your first sign is the same as the expression. So if this is a minus, this is going to be a minus. The second sign is going to be the opposite of that expression. So if this is minus, this is plus. And your last sign is always positive. So that one will be a plus. So here's your steps. They're going to feel very similar. Okay. First one, check for a GCF. Then you're going to take the cubed root, not the square root, the cubed root, using your perfect cubed chart over here of each term. You're going to plug all the things into the formula. And lastly, check your answer. I'm hoping you're realizing the importance of checking your answer on the test. Okay? We've written that I don't know how many times. Okay, so we have our example, 64a cubed plus 1. How many terms do I have? 2. If there's 2 terms, the first thing I always look for is difference of 2 squares. Do I have the difference? Are they being subtracted? No. Okay, so it's not the difference of 2 squares. Since they're being added, the only thing I could do would be the sum of 2 cubes. So that's that first formula up here. Is 64 on our list? Yes. Is 1 on my list? Yes. So it is the sum of 2 cubes. So now I'm going to follow my steps. I didn't have a GCF. And I'm going to take the cubed root of each term. So the cubed root of 64a cubed the cubed root of 64 is 4. The cubed root of a cubed is a. I'm going to take the cubed root of 1. Cubed root of 1 is 1. And then I'm going to plug all the things into my formula. Okay, so I'm using this one on the top. And this first one is A, or 4A is what I'm going to plug in everywhere there's an A. And 1 is what I'm going to plug in everywhere there's a B. So I'm going to have 4A and 1. What is 4A squared? Also known as 4A times itself. 16A squared. 4A times 1 is just 4A. And then I'm going to have 1 squared, which is just 1. So I always do that part first. And then I'm going to go back and fill in my signs, right? So if I'm using soap, the same sign is a plus or positive. Opposite sign is minus. My last sign is always positive. Yes. Yes. Okay. The next one. I have 2 terms. I do not have a GCF. It is a minus, but this one right here, that 3, is not an even degree, so it's not the difference of 2 squares. So I'm going to check to see if it's the difference of 2 cubes. Are 3, 43, and 64 on my list? Yep. Okay, so it's going to be the difference of 2 cubes. So the cubed root of 343 m cubed, cubed root of 343 is 7. Cubed root of m cubed is m. I'm going to do the cubed root of 64 n to the 6th. The cubed root of 64 is 4. The cubed root of n to the 6th is n squared. And now I'm going to plug into my formula. So I have a and b, or 7m and 4n squared. First term here is 7m times 7m, which is 49m squared. My middle term comes from these 2 things multiplied together. So 7 times 4 is 28 mn squared. This last term comes from 4n squared times 4n squared. 4 times 4 is 16. N squared times n squared is n to the 4th. Then you get to fill in your signs. So the same sign, a minus. Opposite makes it a plus. The last one is always positive. The best thing about sum and difference of cubes is this trinomial on the inside will never factor further. Will never factor any further than what it is right now. Okay, so you don't have, this is one of those that you don't have to check to see if it will factor any further. Like you'll never have a double dots or something like that because this is always stuck right where it is. Okay, it's always really nice. All right, so you try these next two. You don't have to write and show all that work like I did if you don't want to. Go ahead and try those next two. Okay, so I'm about to put mine up here. I'm just going to show you, this is how much work I show when I write them out, when I work them on paper. I don't write out all the things like I did last time on those two up there. Okay, I just write the cubed root above them, and then I plug into my formula because it's a little bit less work. Okay, again, this is one you just got to know the formula. You'll get practice with it, don't worry. But you do have to know the formula. If you don't know the formula and you get to one of these on the test, you're going to be in trouble because you're not going to know what to do. Okay, this is not one really that you can factor using your other method like you're used to, right? It's not like the difference of two squares or the perfect square trinomials where you can figure it out another way. This is one you got to know the formula. Okay. And our last page for the day. Are you ready? You're going to be on page 21. So this is going to look a little backwards. And it's 3 by 1s, and you're going to want to put this all the way at the top. Okay, so you may see where it says factor by grouping, and you may be like, hey, we already did that, Stuart. Like, we get it. We know how to do this. Here's the thing. When you have four terms, the first thing you will always try is grouping 2 by 2. Always try this first. Always, always, always. Okay? If 2 by 2 doesn't work, it may be a grouping 3 by 1. And I will tell you now, there is one of these on your test. It is worth 4 points, just like all the other questions on your test. There's only one of them though, okay? So if this is like super overwhelming and you're like, what the heck are you talking about, Miss Stewart? Just bear with me, okay? There's only one, so don't get super stressed out. But I have to show it to you because sometimes grouping 2 by 2 won't work and you'll need to try 3 by 1. But always, always, always try 2 by 2 first because that's the easier one to do, okay? So on this one, we have a squared plus 2ab plus b squared minus 1. So what do we try first? 2 by 2, after we look to see if there's a GCF. Do I have a GCF between my 4 terms? No. So it's not a GCF. So now I'm going to try 2 by 2. I recommend doing this in pencil. Okay. So if I do 2 by 2, what's my GCF in the first 2? A. So then I have A times A plus 2B. That's normal, right? That's what we did when we did grouping 2 by 2. That's how it looked, and it was fine. What was my GCF here? 1. If I take out a 1, then I have B squared minus 1. Are my parentheses the same? No. So grouping 2 by 2 did not work in this case. So now I'm going to go back and I'm going to try to group it 3 and 1. So I'm going to erase all that. Or you can just mark through it and write under it if you want to. So now I'm going to group it, these 3 terms, and that 1 term. So just like when we grouped 2 and 2, you first just cover up that other group and look at what you've got, right? So if I cover up my second group of just 1 term, and I look at these 3 terms together, do you notice that you have a perfect square and a perfect square? So back on page 19, we had a squared plus b squared and a plus 2ab in the middle, right? Didn't we just have a formula like that? So how did this one factor? Wasn't it a plus b squared? So this is a perfect square trinomial. I'm going to write a note to the side that says page 19 so that you know where that came from. So this right here is going to factor a plus b squared. Now I'm going to cover all of this up. I just have 1 term, minus 1. Can I factor that at all? Nope, so I just have a minus 1 right there. So far it's not so bad, right? Because now you have, or because you've grouped it, you looked at your first group and you factored it, your second group stayed the same. Okay, this is where it's going to hurt your brain a bit. Now, is this a perfect square? Isn't it something squared? Is 1 a perfect square? Are they being subtracted? Now you have the difference of 2 squares, which was on page 18. Okay, so this right here is the difference of 2 squares, which you saw on page 18. So we have, for difference of 2 squares, you take the square root of your first term, and that goes in the front of each set of parentheses, right? So we have a plus b and a plus b. You take the square root of the second term. Square root of 1 is 1. You make the first factor a plus and the second factor a minus. That make your brain hurt a little bit? Yes. I'm sorry. It's factored and you're done. Okay. I'm gonna do one more, and then I'll give you the assignment for the day. And hopefully your brain will have a little bit of a rest next period. Hopefully you don't have like chemistry or something. Okay, so number 2, I have 4 terms. Do I have a GCF between all 4 terms? No. Okay, so since there's 4 terms, I'm going to try to group 2 and 2 first. If I do that, am I going to get a common set in the parentheses? No, because here I'd get b minus 8, and here there's not a GCF between those 2 terms. So grouping 2 and 2 did not work. I didn't even have to write it down this time to catch it, right? Since 2 and 2 did not work, I'm going to group 3 and 1. Okay, so cover this up. B squared is a perfect square. 16 is a perfect square. If you have to group 3 and 1, it's always going to fit that perfect square trinomial thing from page 19. Okay, so square root of b squared is b. Square root of 16 is 4. It's the same sign. So you have b minus 4 squared. And then this minus a squared, you cannot factor because it's its own thing, right? So here was my perfect square trinomial from page 19. Now, again, a perfect square minus a perfect square. So we're going to take the square root, use that dots formula from page 18. So you're going to take the square root of this and get b minus 4. And that's what will go first in both sets of parentheses. Take the square root of a squared and get a. That will go last in each set of parentheses. You're going to have 1 plus and 1 minus. Again, one question on the test. Don't panic about those. Okay, so here's all the things that I'm about to tell you. The homework assignment for today, it looks like it's long, but there's really just a lot of space for each question. Okay, lots of space to show your work. It's going to have all the different types of factoring. Okay, so it's going to have factor only by GCF, factor by grouping 2 and 2, factor when a equals 1, factor when a does not equal 1. So that's your AC method or your guess and check. It's going to have difference of 2 squares, perfect square trinomials, factoring by grouping 3 and 1s, and whatever we just did, the one before that. My brain is tired, if you can't tell. What did we do on page 20? Oh, cubes. Cubes. Okay, so it's going to have all the different things. Now, I'm just going to tell you now, on Wednesday, is that when I see you next? Because there's no school Monday. Wednesday, when I see you next, I'm going to come around and I'm just going to check how much of this did you get done. Okay, I'm not going to check the 3x1s because we didn't finish all of those, right? So I'm just going to glance at it. Hey, how much did you get done? Okay, then I'm going to give you the answers to this one so you can check your own, and I'm going to give you the review for your test, and I will give you the answers with the review for the test, because the only way to get better at factoring is to continue to practice factoring. The only way to get better. I hate that for you, but that's the way it is, okay? So then we'll just practice. We'll spend the whole time practicing. I'll fill in the last 2 pages, that page 17 that we skipped, page 22, the last 2 pages in your notebook for this unit. And since we don't have time today, we'll pick up the notes for unit 2, because that's what all this is up here. And then we'll have your test that class period after that. Okay? So that's what's coming up in the next few days.